We're live. Братчик, зайди, проверь, как там лайвстрим. Через Facebook иди на YouTube. Нет, через Facebook на YouTube это не так. Да, через Facebook на YouTube. Через Facebook идешь на YouTube, а потом получается...
Связи нет.
Хочете? Ну иди в Open Wi-Fi. Тут есть Wi-Fi. Или хочешь комьюнити? Хочешь комьюнити Wi-Fi или хочешь Open Wi-Fi? У комьюнити Wi-Fi есть пароль. Угадай. Нажми сам join. О, есть уже один вьювер. Окей?
Ну, сейчас это спали.
Там тарадан 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 пам парапам 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 пам 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 парапам пам 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 там 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 Ой, все. Так, сосредоточились. У нас стримится мероприятие. Ой, меня слышно? Что со звуком сделать?
Чего?
Молчать. Прикинь, мне придется 3 часа молчать. Это нереально. Я могу тебе ответить?
Sveiki, sveiki. Good evening, everyone. Could you please take your seats? Can you hear me all right, by the way? Yeah. All right, wonderful. We're going to start the event shortly because we still have a couple of people running late. So it's going to be a couple more minutes, all right? So bear with me.
Rotate device.
All right, it seems like we have everybody in the house, and I would like to begin by telling you a little story of what City.AI is and what it is bringing to Vilnius. To be honest, it is a community which is global, which has more than 50 cities around the globe, and now we become part of it. So without further ado, I would like to introduce you to what we're trying to bring here. We're trying to facilitate meaningful knowledge and exchange. What does that mean? At the end of the day, we all heard about AI, we spoke about it to a certain level with our peers and our friends, but what is it going to change throughout our lives? Well, this question we're going to try to answer through this intro session into the future of AI. And we have wonderful speakers who are going to indulge you of their expertise and their insights about what they do every day. Without further ado, I would like to move on and present you 3 main qualities which we present with Vilnius AI community, which basically is a local quarterly gatherings. We're going to organize 4 events throughout the year, which means we're not going to go for every month local meetup, because at the end of the day, we aim to gather people on with purpose. As you probably have noticed, we have a lot of posters hanged around the venue, which each one of them represent each city around the globe and what we do in terms of AI in that city. If you probably have spent a bit of time reading it, you probably noticed that we have Amsterdam, which is going deep in media and AI. We have Barcelona, which is contributing to a public sector, and we have even Buenos Aires, which is going to contribute to restaurant scene. And apart from that, we have Madrid, Malta, and all the other cities. But I really encourage you after the event to spend a moment and appreciate it, because at the end of the day, all this information is publicly available to all of us. But it's very rare that we all can come together and share that knowledge with people who actually have their hands to it. With that in mind, I'm going to move to a second point, which is the ecosystem mapping, which talks about the very simple concept of knowing what is the local community is all about. Because we heard about AI, but at the end of the day, how many of you know how many AI startups or companies we have in Vilnius or in Lithuania? How many of you wondered how can they apply AI in their business? I guess many of you, because, well, you showed up to this event. At the end of the day, I'm going to aim to educate people, and I'm going to try to educate through sharing. And this is what we're going to do with each session every 3 months in different locations with different people and different speakers from around the world. Moving on, I would like to, again, point out that we are not a local community. We're a local community which is trying to be global. And with that in mind, we are aiming to be not just another city on the map. We're trying to be part of a global movement of artificial intelligence and how it's going to change and implicate all of us. Not just us, but our future generations as well. With that in mind, we already organized the World AI Summit, which happened in October last year, and which gathered over 2,500 people. Many companies from Google to Facebook, IBM, and all the other biggest players in the field. And with that in mind, by becoming part of this community, we are encouraging you to not just sit, but actually be part of it. Ask questions, learn, and participate. Without further ado, I would like to welcome our first speaker, who is Daniel from SATALIA, a London-based company that provides artificial intelligence and also is the director of UCL Business Analytics, applying AI to solve business and social problems. So, with a round of applause, please welcome Daniel.
Thank you very much. All right. Okay, I have 25 minutes, I think. Okay. Is that going to work? Okay, good. So, hello. Just a little bit about me. I wear 2 hats. I run a master's program in a university in London called UCL. I have about 50 students every single year that go out into the world applying these technologies to solving problems for business and governments. And my entire academic background is in AI. So my undergraduate and master's, PhD is in applied AI. I wear a corporate hat where I run a company called SATALIA, which I'll talk about more later on. And I've started a number of companies in this space. And I guess I also travel the world educating industry and academia and governments about what AI is, what AI isn't, and the impact of these technologies on society. And I guess today I want us to take away two things. I want everybody in the room to understand what AI really is, because there's a lot of misunderstanding in industry. And the second is understanding about innovation and how AI is going to impact the nature of the workplace. And I think there are many startups in the room, and so I think you're going to be quite interested in the second part of the talk. So the first part of the talk is on AI. I'm going to start out very slowly, and this is going to be very interactive. So I want you to try and answer some of these questions. Okay. So I'm going to take you through this this pyramid to help you understand AI. This is a data-driven decision-making pyramid, and the first question I want to ask you all is, what is data? Not quite.
Ones and zeros.
Ones and zeros is good. The data comes from the Latin word datum, which means given things. It's stuff. It's the fabric of our universe. It's not until you give it structure does it become information. So if I say to you 210280, this is data. It's not until I say that it's a date of birth does it become information. So information is here. Okay, so what does this probably say? Huh? Okay, good. What does this probably say? Okay, good. But we can see that the data that's entering your eyes, the stuff in the middle, is the same data, but you're giving it a different meaning based on the context. Okay, so what does this say? Don't be shy.
John read
the letter to Mary. John read the letter to Mary. So picture in your mind, John read the letter to Mary. John read the letter to Mary. What picture do you have in your head?
John read.
It's obvious. John is reading a letter out loud to Mary. Yes? Okay. Anybody else have a different picture? John read the letter to Mary. That's right, yeah, you could be reading a letter that was sent to Mary. What if I said that John is a teacher and Mary is a kindergarten student, they're learning the alphabet, and I said John read the letter to Mary? Or what if I said that the letter is the name of a book, and I said John read the letter to Mary? Or if I said the name of the book was The Letter to Mary, and I said John read the letter to Mary? Actually, this data here has many different interpretations, probably more than 13 different interpretations. And one of the biggest challenges we have in computer science is taking this messy world of stuff, all of this light and images and sound, and trying to figure out what does it actually mean. It's a very, very hard problem. But imagine I give you a spreadsheet, and imagine I've taken some messy stuff, and I've given you a spreadsheet, and that spreadsheet has 3 columns of information. So it has the first column, which is the date. And it has another column, which is the temperature on that date. And it has the third column, which is the number of ice creams that I sold on that date. What do you then do with that information? So it's structured, we contextualize it. What do we do with that information?
Sell it.
Works for Facebook.
Store it.
Store it, okay. Learn, and how do you learn from it? Analyze it, what would you do? So I've given you these 3 columns, what would you do? Maybe you draw a graph. Yeah? So if we had a temperature along the bottom here, we had a number of ice cream sales here, what would our graph look like? Not a trick question. Temperature, number of ice cream sales, what would you see on our graph?
Dots.
Huh?
Dots.
We kind of see, hopefully we'd see a trend that the hotter it is outside, the more ice creams we would sell. Is that correct? Okay, good. This is called descriptive analytics. I'm taking this information and I'm trying to find patterns using visualization. We can do something really cool now. We can do a thing called predictive analytics. We can put a line through it. We can do a thing called linear regression, which just means put a line through it. And now what we have is we have predictive power. So if tomorrow is 22 degrees outside, we can look at our graph and we can see how many ice creams we're going to sell, even if we've never ever seen 22 degrees before. So we've got predictive power. And now what I've done is I've created some knowledge. I've extracted some knowledge about the world. I know that I sell more ice creams when it's hot outside. And I could take this knowledge and I could implement it into a factory, an ice cream factory. And I could sit back and I could let my autonomous AI factory sell ice creams and sit back and let the money roll in. But what if tomorrow is going to be the hottest day ever? So what will my factory do according to my model if tomorrow is the hottest day ever?
You'll produce a lot.
My factory is going to produce many, many ice creams. Okay, so but what will really happen if tomorrow is the hottest day ever?
Nobody will buy.
Nobody will. It's good. It's very fast. So yeah, our model of the world is wrong. Right? This is not the correct model of the world. Our model of the world probably looks something more like this. Why do we? Can anybody tell me why we sell ice cream? Ice cream when it's hot outside. Not a trick question. Why do we sell ice creams when it's hot outside? Okay, so I'm inside. It's hot outside. What's the first thing that happens?
Melt.
Huh?
Melt.
No, I'm inside. It's hot outside. First thing that happens? I go outside. Very good. And then what happens? Why do I go outside? Okay, I get hot, and then what happens? I want an ice cream, so I buy an ice cream, then what happens?
Cool down.
I put it down my pants, what do I do with the ice cream? Huh? I eat the ice cream, and why does eating an ice cream cool me down? Thermodynamics. Okay, so, but to expect a computer to understand that narrative, to understand that we go outside, we want to be hot, we get too hot, we can choose different things, we can cool ourselves down in different ways. So expect a computer to understand that is a big problem. And so there's a difference between people that are really good at finding patterns from data, the data scientists, with the people that have domain knowledge to understand and interpret those patterns. So these people, the understanding people, have a domain knowledge to help us understand how to create narratives around those patterns. Because ultimately we want to understand the world so that we can make good decisions, so that I can sell as many ice creams as possible. And it turns out that humans are really bad at making decisions. Right? We're really good at finding patterns. I'm really good at understanding who's the males and females, and really good at understanding how to take this sound and extract meaning from it. But we're not very good at making decisions. And let me give you a few examples. So I'm going to ask you a few maths questions now. We're going to start out very easy. I'm going to get more and more complicated. And your job is to answer these maths questions as fast as possible. Because if you don't answer them as faster than your competitor, then they're going to win your market. Okay. So has anybody read the book Thinking Fast and Slow by Daniel Kahneman? Okay, don't answer these questions if you've read this book. So the first question is this. The combined price of a bat and a ball is €1.10. The bat is €1 more than the ball. How much is the ball? 10 cents. No, it's not. So the bat is €1.05. The ball is 5 cents. The combined price is €1.10. The bat is €1 more than the ball. Yes? Huh? 105. So it's okay that everybody that said 10 cents, you're not broken. Humans are biased. We are really good at seeing and hearing patterns, but we're not good at making these simple decisions. And I can give you hundreds of these examples where you'll get the answer wrong. We think we're good, we're not. And the idea of modeling kind of artificial intelligence on human intelligence is a bad idea because humans are not very intelligent. Let me give you another example. So imagine these are staff members. So these are your staff members. And you need to figure out how to allocate your staff members to projects. Okay, so imagine you know everything about these staff members. You know whether they can fly or walk or swim or whatever. And I ask you to orientate these staff members in a way that satisfies these rules. Okay, so flying staff members have got to be the right of walking staff members, and no same colours are allowed to touch each other. How many possible orientations are there of these 5 staff members? So here's one orientation. I can flip. Which is what? 5 factorial? 5 times 4 times 3 times 2 times 1? 120. So the 120 possible orientations, many of which won't satisfy these rules. Some will satisfy the rules, but only one will be the best one. Okay? Make the problem a bit more complicated. 10 staff members. How many possible orientations are there? Huh? Guess? More. So there's over 3.5 million possible orientations. 15 staff members. As your companies grow, 15 staff members. How many possible orientations? Even more. So over 1 trillion possible combinations. So 15 times 14 times 13 times blah, 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 into your calculator, you get this number. These are relatively easy problems for computers to solve. But most companies have problems of this size. So 500 staff members. How many possible orientations? 500 times 5 and 499. Anybody? No? Gazillion. Correct answer, actually. So this is a gazillion. This is a very big number. And just to put this into context, this is how many atoms there are in the universe. Okay, and your job is to figure out what's the best combination to utilize your staff. And to again put this into context, one of my clients is a large consultancy company, and they have 200,000 staff members. 200,000. You have to figure out they've got 400 people who are trying to work out how to allocate these people. That's their full-time job. Humans are not very good at solving these problems. And the reason why I talk about this is because everybody's excited at the moment about machine learning, about finding patterns in data. But once you've found patterns, you need to be able to use that understanding to make good decisions. And this is the world of optimization. Okay, so imagine I've got a factory and I have an ice cream van, an artificial ice cream van, and my ice cream van has to visit these 24 points. Okay, so if I'm starting here, and if we wanted to draw a good route around these points, the one that will save the most amount of petrol, where would you go first? So if I'm here, where would you go first? Huh? Okay, here, then where? Close, okay. We could probably, after a few minutes, we could probably draw quite a nice route around these points. How long will it take a computer to come up with the best solution? Not very long. You know the trick questions now. 20 billion years. So we've played this game already. So we have 24 times 23 times 22 times blah, blah, blah. It's your calculator, you get this number. And if you have a computer that can look at 1 million routes a second, that could check 1 million routes a second, it would take 20 billion years for it to go through all of the possible routes and say, this one I looked at 10 million years ago, this one's the shortest one. If I had another point to the map, 25 times 20 billion years. If I had another point to the map, 26 times 25 times 20 billion years. And again, to put this into context, one of my clients delivers to 100,000 points on a map a day. 100,000. They have milliseconds between each customer coming in to optimize, to be able to optimize those vehicles. So again, this is the world of optimization. And it seems that almost every company at the moment that touches either data or machine learning or even optimization are calling themselves an AI company. And it's okay if you're doing that. You get more money from VCs and things like that. But this is still not AI. Okay? The best definition of intelligence that I've ever found is this one. It's goal-directed adaptive behavior. So goal-directed is I'm trying to achieve some objective. I'm trying to sell as many ice creams as possible, or I'm trying to route my vehicles to minimize the amount of petrol, or I'm trying to allocate my staff to maximize utilization. So I have to have a goal. Behavior is, can I allocate my resources to achieve that goal? But the key word in this definition is adaptive. If your system is not adapting itself in production, then it's not AI. Okay? What traditionally happens in industry is companies will buy an IT system, they'll run it into production for maybe 3-5 years, and then they'll replace it with a new system. This is how they used to adapt. And now what we're doing is we're building systems that are modular, that you can replace the parts. Okay? This is currently how systems are adapting, where you would build a system for a company, you'd run that system, you give it some data, it makes some decisions, you then give the data to a data scientist, they extract patterns, they improve the model, 6 months later, they update the system. This is how systems are currently adapting in industry. But the real paradigm for AI systems are systems that can adapt their own model themselves without the aid of a human. And I've seen very, very, very few successful systems in my entire career that do this. And if you're all being part of AI startups, and I'd ask you to aspire to building systems that can adapt themselves. It's very, very, very hard. They can start to adapt in ways that you can't predict. But that, for me, is the true paradigm of AI. Yes? YouTube? I don't think so. No, I suspect that the data is given to data scientists. Yeah. I think we'll talk about that later. Okay, so there's two types of AI. There's one called Symbolic AI. This was very popular in the 60s and 70s. So this is one of my favorite paintings. It's Socrates. Socrates is famous for the Socratic method. So the Socratic method is Socrates is a man, all men are mortal, and from that I can infer what? Socrates is a man, all men are mortal. That Socrates is mortal, so I can infer new knowledge from these basic rules. And we thought that we could build these basic rules and then allow computers to infer new knowledge and start to behave intelligently, but it didn't really work. And then in the 70s and 80s, a new type of AI came along. This is the brain of a bumblebee. Bumblebees? Bumblebees have 1 million neurons, smaller than the end of a needle. Okay, but bumblebees do amazing things. They can fly around in 3D worlds, they solve problems, they communicate with each other. They're very, very, very smart, but my PhD was trying to model the brain of a bumblebee, and in the early 2000s, this was still very, very hard to do. And then people realized that these neural network things are not going to work. And then what happened 10 years later, or 20 years later, was that we had lots and lots of compute get created, and we had new ways of building very, very big brains. And now what we can do is start to build these neural networks that can do things that humans can do. It's very, very exciting. It's called deep learning. I'm sure that many of you have heard of these things. Okay, and I guess industry are realizing that if they use these technologies, if they adopt these deep learning technologies and optimization technologies, we can build systems that can outperform humans now at almost anything. If we really put our mind to it, we can build systems that can outperform humans at anything. And if you imagine this is the bounds of human ability, bounds of our ability as humans, we can build systems that can outperform us. And this is kind of inefficient, building these individual systems. So there's this drive towards trying to build what is called AGI, artificial general intelligence. And these are building systems that don't just do one thing better than humans, but can do a range of things better than humans. And this is still very much in R&D, but this is where organizations want to go because it saves them more money and things like that. And if we extrapolate this out over the next several decades, then we're going to build a brain that's smarter than us in every single possible way. Okay, it will be the last invention that we ever create. And it's often referred to as a singularity or superintelligence. And nobody knows what's going to happen if we build an intelligence smarter than us. It could be good, it could be very good, it could be very bad. It's regarded actually as our biggest existential threat. And I spend a lot of my time thinking about how to prevent this and how to make sure that we are not in we don't have a big problem if we do make it happen. Some people actually think that it's already happened. So if you look at the size of our universe is very, very big and it's very, very old. And the likelihood of there being intelligent life in our universe is actually very high. And the likelihood of that intelligent life reaching a point technologically where it creates a superintelligence like we might over the next 30, 40, 50 years is also very high. And there's this concept called the Fermi paradox, which is given the size and the age of the universe, the likelihood of there being superintelligence in our universe is very high, and we don't see any sign of life when we look into our universe. And the hypothesis, the theory is that we're living in a simulation created by a superintelligence in a different universe. No?
Maybe in our universe.
Huh?
In our universe.
No, it's a different universe. This is a computer simulation. So people like Elon Musk and whatnot think about this. Okay, but before we create superintelligence, we are creating dumb intelligence. We're having to build systems that are making decisions about our everyday lives. And Domas later on is going to talk in more detail about this, but you've all probably heard of the trolley problem. So if I'm in my driverless car, in front of me is a kid, to the right I have two adults, and to the left I have a cliff, and the car can't stop. Who do I kill? Who does the car kill? Huh? The kid? The cliff? What if you have a kid in your car? Oh shit. Huh? It's hard. So for 2,000 years, philosophers have been figuring out what's the right decision in these situations. And what's really interesting now is that we're having to build systems that embed these ethical decisions. It's very exciting. So I'm particularly interested in a concept called ethical verification or explainable AI, and Domas is going to go into much more detail about this later on. This is very, very hard to do. Right? Governments are going to be legislating for companies to make sure that they can build explainable AI, and it's extremely difficult. Okay, innovation, very quickly. So the best definition of innovation that I've ever found is this one, by Steve Jobs. He said, innovation is creativity that ships. So what's the most important word in that definition? Who thinks creativity? Who thinks ships? Okay, I think it's the word that. So that is the process of taking ideas and getting them to the point where somebody's willing to give you money. And that's the process of innovation. And the entrepreneurs in the room, you embody that process. You have an idea, and you spend many, many years trying to get to the point where you can sustain yourself by people giving you money. And I suspect that over the coming decade, we will end up commoditizing this technology stack. So cloud computing is already very cheap. We have access to lots of data. We already have access to lots of free tools that allow us to find patterns in data. And I'm sure at some point we'll have free access to systems that learn and adapt. The big battleground is not going to be for technology in the next decade. It's going to be for talent. And the question is, how can you attract and motivate the best talent in the world? And I'm really interested in motivation. One of the best books I've read about motivation is by Dan Pink. It's called Drive. And he said there are 3 things that motivate people: autonomy, mastery, and purpose. Autonomy is giving people freedom to do whatever they want. Mastery is giving them the ability to become really good at what they want. And purpose is giving them something higher to align themselves with. And what I'm seeing, I help a lot of organizations understand where they are on this matrix. And if you want to attract talent, you need to understand where you are. So the first dimension is how sexy is your brand or your industry, and the next one is how interesting or challenging are your problems. And if you're not sexy and you don't have problems, you're not going to attract talent. If you're sexy and you've got problems, you're going to attract talent and they'll stick. They'll stay with you. And if you're in the other 2 quadrants, you'll attract talent, but they'll leave. They'll leave after a few years. And this can be more dangerous to your organization than being here. So understanding where you are on this matrix will help you understand whether you need to build out your own team, whether you need to work with third parties, whether you need to do some sort of hybrid. Very, very important that you're honest with yourself about this situation, because many of you will be receiving venture funding and things like that and thinking that you're going to be able to build out your own AI teams. And the likely scenario is you're not, because the competition for talent out there is extremely difficult. But once you've attracted talent, the next thing is to figure out how do you enable those talent to thrive. I just want you to take a moment now. I don't know how many people have worked in industry before, but just take a moment to read this slide, if you can. So this is a hierarchy. And when you start to create hierarchies are very good for communications, but they create politics and they create inefficiencies. And if you want to create an organization that's genuinely innovative, you need to rethink this model. And I'm really interested in figuring out how to use AI and technology to reinvent how organizations run. So it used to be that organizations were quite fat. They had lots and lots of layers of management. And over the past several decades, organizations have been trying to thin them out by removing middle managers. But this doesn't solve the problem. I'm actually interested in creating completely decentralized, self-organizing companies. So for example, in my company, we have about 70, 80 people. We have no managers, no hierarchies. We have no concept of holiday or expenses. People are completely free to do whatever they want. In fact, actually 6 months ago, we had everybody in my company make public recommendations for their own salary. And then people voted on whether those salaries should be reduced or increased or accepted. And we work very, very closely with Domas's company, Datadog, which is 40 developers in Kaunas. And we had Datadog employees voting on our salaries. So I had Datadog employees voting on people in my company salaries who were more weighted than my vote. And the way that we use technology is we think that we try to use technology to identify who the best decision makers for a particular problem. So if I was voting on your salary, the weight of my vote would be a function of 2 things. One is how closely have I worked with you over the past year? And the second is how highly regarded I am as a strategic decision maker. So we can look at all of our data, we can look at our Slack data, our Jira, our GitHub, our email, and we can understand how are people connected and who are good at making certain decisions. Yeah? And then we were using these weightings to be able to allocate people's votes. It was really interesting because we had many females that were undervaluing themselves, which is very, very common in industry. And when we had the company rally around those females saying, you're worth more than this, you need to increase your salary. So it uncovered a cognitive bias and fixed it. So, so I'm interested in how we can build systems that are ethical, but there's a question about whether we're building ethical systems. And so I don't have a big problem with Facebook, but ultimately Facebook's goal is to try to make money for their shareholders. And Facebook's goal is to try and have as many people looking at that screen as long as possible. And it's you versus 9,000 PhDs whose job it is to keep you looking at that screen. And who's going to win? And they tap into your dopamine, they show you things you don't want to see to then give you a hit for something that you do want to see. And once these companies own these worlds that we're going to be living in, these worlds are going to be amazing. They're going to be able to fly and do all sorts of crazy stuff. And this world here is going to be boring in comparison to that world. But I have to ask myself, those companies that are creating those worlds, they're doing it to try to capture your attention, but what impact will that have on our social development, on our brain development, and things like that? And so the question is the product that you're building, is it going to contribute positively to society or negatively? So just to close, the purpose of my company, so we do a really good job of making everybody free and helping people to become really good at what they want to do. But the purpose of my company is to figure out, in this future world over the next couple of decades where AI is going to free more and more people up from their jobs, it's often called the economic singularity. So the first singularity I talked about was called the technological singularity, where we build a super intelligence. But before then, we're going to probably reach a point where AI is freeing many, many, many people up from their jobs, and it could cause some social unrest. And what my company is trying to do is figure out how do we use all of these innovations that we're building for some of the biggest companies in the world, and then repurpose them to try and solve this future problem where people don't have to work. And so the purpose of my company is to enable everybody to do what they love. And that's the thing that really drives the people that work for me. That's it.
Does anybody have questions? Or would you like to wait until Domas finishes and we're going to have a longer session for everybody's questions? I'll take it as a yes. So next we have Domas from Data, who's going to introduce us to the ethics of AI. Yes, next. And that's Daniel, and then next we have, and the next one, then this is you, and then after you, you have you.
Hello. Hello, everyone. Just for me to understand a little bit, how many of you are software engineers or data scientists? Something like that. So, question for everyone else. Do you trust software engineers for building systems or potentially AI systems? And what kind of impact do you think those AI systems may have on your daily life? And one day, if you get hit by a car, and if it is a self-driving car, would you want to understand why did the car hit you rather than harm the passengers of the car? And the thing is that data is regulated already. GDPR directive is coming in May. But what is not regulated is how countries and companies deploy artificial intelligence. And the artificial intelligence that I am referring to is not the super intelligence or generalized intelligence. It's rather the common understanding of AI being a set of technologies, an umbrella of technologies such as deep learning, machine learning, natural language processing, and other similar expert systems like scheduling, planning, optimization, and so on. But the thing what worries is how easily can these systems be tricked or fail, and the impact that fail might have. One of the core technologies of that umbrella of AI is machine learning. And for people, it's usually difficult to understand how that really works. And the easy example would be to imagine if you have to train your child to recognize Spider-Man. And imagine if you would show hundreds of thousands of pictures with Spider-Man in it, and your child would start recognizing the Spider-Man. But if you would introduce a new object or a new person in that, in the image, let's say Batman, child would not recognize who the Batman is. And the thing is that it's quite easy to trick the neural networks. An example here, one neural network was trained to recognize wolves and huskies. But when given a photo of a husky, the algorithm still identified it as a wolf. And the authors of the algorithm were not able to understand why it happened, so they reverse engineered it and realized that the training data was biased, as every single image of the wolf that was given to the algorithm during the training period had snow in it. So every wolf was in snow, and the husky that the algorithm was trying to identify and classify had snow in the background as well. So they have simply realized that actually the calculation that the neural network gave away, assessed probability of it being a wolf in a photo, was because it's not identifying or looking at the actual object, the main object of the photo, but rather the background of it. So another issue with biased data is that sometimes people are biased and subjective and treat the data in the wrong way, meaning that they build biased systems with biased data. And one of the major tech companies trained their facial recognition system with biased data, where they used mostly light-skinned faces. And their facial recognition system was able to identify white males easily, but when it comes to black females, the error rate shot up to 30% or something like that. Of course, one of the most well-known examples of human bias was Microsoft chatbot on Twitter. Probably you've heard about that. The chatbot going all Nazi and then, like, in a day or so, shooting thousands of tweets full of hate. And at the same time, US courts are already using a system called Compass, which helps the judge to decide if the defendant is likely or not to commit a crime again. But a recent study revealed that actually this system, Compass, is more likely to identify black or Hispanic person as recidivist and willing to commit a crime again compared with white people. And the other issue is that most of those AI systems are black boxes, meaning that the companies behind these systems are not willing to reveal how it works. Of course, they have a right to say that, you know, it's our key secret, trade secret, and the most important part of the business. But then again, if it is easy to trick these systems, would you want to know why the self-driving car, decides to hit you or a brick wall? And some of the other examples how easy it is to trick these systems is applying noise for like light distortion on images that were actually used during the training process of the machine learning neural network. And if you apply noise on the image, the human eye will still recognize the object in the photo, but you might trick the algorithm. And there are many cases where pandas were identified as gibbons, or washing machines identified as loudspeakers, school bus identified as ostrich, and Queen of England identified as a woman wearing a shower cap rather than a crown. And it's just a few changes for the photo itself. So what should we do to start understanding how it works? The main thing is that at the moment the process is getting some training data, going through the learning process, and we get an output, which is a calculation, a probability of the object being something that we're looking for. What we need to get is a new learning process and generate an explainable method, and at the same time explanation interface, where the system would say that, okay, this is let's say cat in a photo. And I think that it's a cat because it has whiskers and fur and claws, and I have identified these parts of the body of the animal, and that's why I think that this is a cat. And at the same time to show that, well, the example with wolves and huskies is a great one, because it would also show that it's probably paying attention to the body or background of the photo. And the most important thing is that everyone who is building powerful systems, there's responsibility to think about how these systems might be used. It's also ethics that must be a top priority for us. And it's inevitable that we will eventually build a system that is capable to adopt, capable of making new decisions and to learn, and maybe it will be conscious. The question is when it will be the day. And in the meantime, we need to take all the precautions to get ready. So let's say Defense Projects Agency, DARPA, is funded with $75 million to support the idea of explainable artificial intelligence. But the ISO, International Standards Organization, created a team, and they said that they need another 5 years to decide what to do with AI-driven systems. And that's too long, I guess, because we are already using these systems in our daily lives. And what we need to fear is not killer robots, or it's our own intellectual laziness. And I think that we can solve most of our challenges as humankind, but to do that, we need to lead rather than following. And that's it. Daniel, will you join me for questions?
Thank you, Domas. Let's call Daniel as well.
Nice one, Domas.
Yeah. So now it's time to ask questions. Does anybody want to start? Yes, please.
You talked about explainable AI, and when people found out that the data was removed as a white background, what is the process of debugging?
Of debugging
How did you find out where is the...
I am actually not aware, but I guess they have studied the data manually. That would be my guess. Reviewed the training data.
So I can answer your question. If you don't mind.
Sure.
The method is called LIME, locally interpretable model of explanations.
That was quick. Anybody else? Please. Yes. Let me just. Yeah, take a look at the line. It's locally interpretable model agnostic explanations. What it does, it basically takes your model and takes a point and randomly samples around that point and helps you understand what is the local boundary. So in the case of the images, it simply spots the white snow around and says that I made a decision because this is snow. Thank you. Kept good. All right. Somebody else wanted. Yes, please.
Lots of food for thought about how we should be leaders in terms of not going the wrong way. Humans, we know that humans are really bad at self-policing. So do you both touched upon this idea that there's probably going to need to be some sort of regulation interference? But how do you imagine this? And going back to the Facebook question, I struggle with the thought that I understand their objective function is to maximize the time engaged with the platform. That's what their company is built upon. When do we come to the point when we realize that this is really socially bad maximization function? I mean, we went through this with cigarettes. We as a society realized that they are bad for us, and now we're doing everything to prevent that. When will we as a society realize that we are addicted to a technology that is bad for us, it is bad for our functioning, certain ways to function, and how do we control this? Because the objective functions are not aligned.
So I think that the objective function for the planet currently is capitalism, which is how do we maximize the GDP of a country, and to maximize the GDP of a country, you need to figure out how to utilize your resources as much as possible. That means squeezing your people, squeezing your environment, building infrastructure to allow people to build innovations that ultimately you can sell to other countries to get to export. Okay, so this is very simplistic understanding of the world. And I don't think that that model is sustainable. And I think that there's a movement around what people are calling post-capitalism at the moment. This idea of organizations. Ultimately, there's a handful of organizations that are accumulating much of the wealth and much of the power. And I'm not convinced actually that legislation will happen. I would like to see it happen. I think we should encourage countries to legislate against it. But my assumption is that these companies are smarter than countries. And they're bigger than countries and richer than countries. And so they're the ones that are going to win. And so I'm interested in, I mentioned it briefly, this concept called decentralization. And I think that there is a way to remove the concept of a company. And it touches upon transparency and whatnot, but we are trying to build a platform that enables anybody from anywhere in the world to come together and contribute to a product and to be rewarded for that contribution. So you could be a software developer, an accountant, a designer, a data scientist. You could be sitting in India or China or anywhere in the world, and you can choose, not necessarily be employed, but you could choose who to allocate your time to, and you could be fairly remunerated for that. And if we can make that platform work, I don't think that you need to have a company to create things like Facebook. As far as I'm concerned, if you can make that happen, you don't need to have a company for Facebook or Google or Airbnb. So Facebook's interface, I'm pretty sure that if we got together, there's lots of developers in this room, for the next year, we could probably recreate Facebook's interface. Now, Facebook has 2 billion users, and if each one of those users paid $1 per year to have access to that service, that's $2 billion a year, which is more than enough to service a community of people building that open Facebook. Even if you paid 1 cent or 10 cents a year, who would pay $1 a year to be able to access a free, an open version of Facebook that's not driven to keep you addicted to that screen? Right? Huh? If it's popular, of course, you've got to be able to migrate. But I would migrate if I knew that this thing was community driven and all this kind of stuff. So I think the first thing is decentralization, and I'm passionate. I've got a 30-year plan to try to figure out how to decentralize the world. But the second, about self-policing, just very quickly, I want to ask a question of, this is a thought experiment. But what if we could flick a switch and delete all of your data, all of your naughty data, and then from now on, all of your data is open. Everything that you do is open to everybody. So if imagine what would happen if I opened all of my bank details. What would happen? If I opened up my password, my bank details, what would happen? Huh? So people would take money out of my account, right? But what if that data was open? What if I knew who was taking money out of my account? What if everybody else knew who was taking money out of my account? Would people take money out of my account? Huh? I could take it back again, because all data is open, right? I could just take it back.
Can you do that?
You could have my student debt as well if you wanted it. But it's an interesting thought experiment. If everything that we did was open, would we self-police each other? And at the moment, you've got a handful of companies that essentially have access to everything you do. Google, Facebook, Amazon, whatever. They know everything about you. And the question is,
Wouldn't that depend on your social you have no friends and like, hey guys, this guy's not doing right. And then if you have many friends, and it's like, hey guys, like this.
if somebody does something bad to somebody else on the street, you step in, right? You don't leave it to their friends to come. You're like, that's not cool. So I would step in and say, that's not happening. It's an interesting thought experiment. And I want you to think about it. Would we be living in a better world if everything was open? And trolls are a really good example. There's this, sorry to diverge, but there's a very good book by Plato called The Republic. And in the Republic, Plato talks about the myth of Gyges. Gyges is a shepherd, and he finds a gold ring, and he puts the gold ring on, and he becomes invisible. And what does Gyges do with this power of invisibility? Huh? Yeah, have fun. he seduces the queen, and he kills the king, and he takes control over the kingdom. And if people can get away with bad things, they tend to. And Facebook was built on that idea, but it's then now it's to service shareholders. You know, Google was built on the idea of these things, but once you start to get investment, and once you start having to answer the shareholders, you take your company on a different journey. My company, it doesn't have any investors, right? I'm not going to take investment from anybody because I don't want to answer to VCs. I want to be able to be free to do the things that I want to do. They wouldn't let us do these crazy things with Datadog and have people voting on our salaries, but that's the stuff I think is going to change the world. Yep. And so I think what will happen is that people like you and me will react to that world, right? There's going to be, I think it is enough. I think it is. I think it's possible. If I didn't believe it was possible, I'd be on an island somewhere having a very good time. But instead, I spend my energy trying to figure out how to solve these problems. And if I didn't believe it was solvable, then I wouldn't be. But I do genuinely believe. I meet lots and lots of people that want to make this happen. 100%. Yeah, so blockchain is going to be probably the foundation of providing this data for everybody, and then AI is going to be a layer on top of that to help us operate. Sorry to... Okay. We're probably about 25% there. I think we've probably got another 3 years before we have a platform that we can make available to the world. If we got some money in somehow, we could probably accelerate that. But I think that in the next 3 years, we could build a platform that we can give to the world. And once we do that, then everybody else can start to build decentralized organizations. We make money by building cool stuff for companies. We help them make money, and then we take some of that money and we invest it in these internal technologies. But if anybody's got money they want to just give away, I'm happy to use that.
Yes, I propose use the hand and give the microphone, because when you ask a question here, no one hears the question back there. So raise a hand. Yeah.
Any more questions? Anyone?
I'm gonna have a question, maybe not a question, but just you said to think about I'm gonna call it energy of free data. So comparing to normal energy, where everyone would be like, the self-policeman would be like some of the sorts like, hey man, that's not nice, stop this, and the people would actually see the bad behavior and they would try to stop it, because they don't want to see it around. But if you're in the free data thing, you don't actually see the people, you only see data. So how can that be a good thing that everyone can access my data and, like, I don't know, use it, change it, and I have no way of policing it or even imagining how anyone else would police it?
If it's on the blockchain, they can't change your data, but you can understand what transactions are happening. So if somebody's taking money out of their account, that's captured on the blockchain. I guess the goal is to try to figure out a new model for capitalism, and then somebody needs to work out how to apply these ideas to solving the judiciary problem, how do we solve the justice legal problem, and then we need to work out how to create a decentralized government for the world. And that's kind of like the 30-year plan.
Another question?
Okay.
Closer? Oh, fine. Okay. So another one would be back at the car experiment. I keep hearing it, but I never hear like some more details about it. But I'm really interested in that. I understand that possibly the best way to solve that problem would be to give some sort of a value to every person, and that value would be like calculated on like things you like, maybe things you like, your status in your society, maybe in your government. And is that the way we're going, or how are we?
So I've heard different philosophers have been thinking about this for many, many years, and some people think it should just be random, that that's the fairest solution, just random. Other people think that what will happen is that we will have an ethical setting in our car that we choose to determine whether we want to save dogs or cats or children. And then the responsibility is on us instead of on the car manufacturers because they don't want to be liable. I heard a crazy thing recently where they would scan your brain and look at your behaviors and try and replicate your personality and put that personality in the car. So
basically, I'm going to shout.
Shout.
All right. So basically, by saying that, you mean we're gonna give personality to cars? Like we're gonna give brains to cars? Like we're gonna let them make the choice themselves?
I hear these things and I pass these things on to you. You work out what to do.
Like there is a lot of like discussions about how algorithms are biased and how like they are easy to click, but like people are also easy to click, and one and main difference is that we have a person responsible, but like algorithms, they still in a lot of situations they do better decisions. We just don't have who to blame for them. And why we spend a lot of time on talking about how we're easy to click, but we also are easy to click.
But the thing is that systems can do thousands of repetitive tasks per second, minute, whatever. So you would most likely catch the bad person faster than identify that the system is doing something wrong. I mean, it can do damage quicker than a human person could do, potentially. That's just one of the reasons to think about that.
I think that some algorithms right now are not as smart as humans, but my expectation is that over the coming years we will build machines that are much smarter than us.
Because like in the example with the car, the human also have to do a decision that usually we do not manage to do it in time, and we just like do nothing.
Yeah, like Domas said, a computer can make thousands of calculations and has a much broader view of all of the data and things like that. And I agree with Domas. The machine's going to be able to make ultimately a smarter decision than us. Give you one more example if you want. So imagine you have a burning building, and in the burning building there's a crying baby and a suitcase with 100 million euros. Okay? And you can only save one thing. What do you save? Huh? Crying baby, right? We would naturally want to save the crying baby, but maybe a computer will work out that with 100 million euros it could save millions of babies. Which is the right answer? I don't know.
I guess we will have to wait to find out.
Sorry.
All right. Any last questions? Last one.
Where to start? I don't know if you want to recommend those.
Just where to start if you don't do AI already.
There's loads of cool Coursera courses to go and start to learn about these technologies. Very quickly people get bored with the Coursera courses and they drop out and they feel like they haven't achieved something, but it's okay to drop out. Once you've reached a point where you understand the basic technologies, I would then apply those things to things that you're interested in. So go and get some public data. There's lots and lots of data out there. Go and start to build some of your own models. Apply it to things that interest you. So don't worry if you don't complete the courses. Just get enough knowledge to go and start doing some interesting things for you. And then start to build up a portfolio. And go to networking events. Like this.
Thank you. Thank you. And now we're going to move to the third speaker who's coming straight from Exacaster. At the other side is Rokas Tamošiūnas. Please welcome him.
Okay.
Maybe some technical issues? No?
Should work.
Should work now?
And the next
Yeah, it's me. Good. Okay, so hi. I will mainly talk about our R&D initiative, but first I want to jump into and tell who I am and who we are. And I come from Exacaster, and at Exacaster we try to build business intelligence solutions using, well, actually machine learning or AI, depends how you look at it and depends how you define AI. So maybe your definition is too harsh for us, but at least we are trying to head that direction. And the things which I will talk later on, they will become proactive. They will manage to satisfy your definition sooner or later. Okay, so what we have there? We have a data lake, which is Hadoop infrastructure, and we need to store the data somewhere. And we have different business solutions which we offer. And basically we try to sell you stuff. Actually not to sell the stuff like we are selling stuff, but to help businesses sell their products, and this is mainly telco and retail. But with all of that, we have a big part of things going on in our R&D department. So what we do there, we explore. And this exploration usually don't lead anywhere, or sometimes it leads to techniques which we apply and sell and do something with that. And this is the project which I will talk about is halfway into. We're working on it for 1 year, and we have 1 year to finish it. So we are just in the middle, and I think we are quite far, and we just need to connect everything correctly. And what we had to do, we thought, okay, let's build AI-driven business intelligence analyst, just like that. Is this possible? Well, maybe. But the first question we should ask, is this desirable? So, should we do that? Well, I think it's imminent, and I think it will be done sooner or later. So, why not to try that out? Another thing, is this useful? So, first thing, will analysts lose jobs if we manage? Well, not actually. They will shift from the things they do now to more interesting things. For example, you can delegate simple things like to check some sort of business KPIs. You can do that by asking chatbot or any other interface a question and getting the answer right away instead of spending some time writing SQLs, going to connecting to the database, and so on and so on and so on. So this can be useful. And from a manager's perspective, maybe you are spending too much time delegating works for analysts, which are really, really simple, and you can have an automated BI analyst somewhere in your, for example, Slack, and you can just ask a question and get an answer right away in the middle of discussion with another business manager about some issue or something like that. It would be awesome. Okay, is this possible? Well, I'm not sure. We have some of the building blocks. We think that when you connect everything, maybe we are really close, and it's already useful. I will show you bits and pieces we are already using. But there is one missing ingredient which I will head into the other end, and maybe someone of you will help us with that and come up with a clever solution. Okay, so what's the building blocks behind that? First, we head into building Explainable Analytics API. So this is the simplest thing you can do with time series. You can analyze them in different ways. So we built an API. This API is open, and you can head into analytics.exacaster.com to check that out. And what this thing does, it makes some things really fast and really simple, and you can call API and get an answer right away. And it does simple things like detects outliers. So these green boxes mark that it sees outlier there and there. It's quite clever. It can detect outliers which are sometimes hard to detect. For example, this one right here would be missed by most of the methods. We use dbScan behind it, so dbScan is usually a clustering algorithm, but there is a clever way to use that for time series. Next thing I can do, I can say, okay, find me a change point. It says, yeah, here you go. It's a change point. How to do that? Well, you can look at the Bayesian methods, and we use Bayesian, online Bayesian detector, which basically tries to model and tries to find a change point by modeling previous and post sequence behavior. And it sees that the behavior changed at that point, so this is the change point. So we have both of those anomalies there. Okay, change point. We can detect periodicity. If the sequence is periodic in some way, we can detect that. This is done basically using Fourier analysis and some clever peak point detectors. And we can predict the future. So this sequence actually, it looks simple, but it's quite complex, and most of the methods which are used would miss it. We use neural decomposition behind that, which is quite recent. And another thing we also did, which I forgot to put there, is we asked Analytics API to interpret what it sees. So if it sees increasing sequence, it says, oh, I see the increasing sequence. If it sees a sequence which is sinusoidal shape, it says, oh, I see a wavy sequence. So it looks at the image as you do, and using convolutional neural networks, he says what he is thinking he's seeing. So this will come important later on when I speak about interpretable decisions. And then we decided, okay, we have those building blocks, but can we do something more clever than that? And we need some sort of clever interface than only using an API. And we head into building chatbots. So chatbots, from my perspective, I think that chatbots is the interface of the future. There are a couple things why you should think so also. So first thing, 4 years ago we switched to mobile phones. So we are using mobile phones more than we use our personal computers. And the thing happened like recently, 1 year I think, we started to use chat interfaces and chats like WhatsApp and so on, much more than we do using Facebook. We use Messenger much more than we spend time looking at it. So most traffic, most internet traffic now, from the human perspective, is via chat. So chatbots should be quite natural, and there might become an age when there is a clever chatbot in your, for example, personal chat, and when you deal with a person to meet at this hour at that place, it just adds it to your account. Why not? So these chatbots are possible, and they should become a part of that chat interface which we have. Okay, so we first thought, let's do a simple thing. Let's make a chatbot which does two things. It can small talk a little bit. So if I say hello, it says hello. If I say, how are you? It says, well, I'm fine. And it can interpret SQLs. So by interpreting the SQLs, I mean he can answer such questions which are broken. These are quite complex. These might require grouping, aggregation, and so on. But I need to translate them into SQL, run that SQL, and come up with an answer. So in case I don't figure out how to make a nice graph, I will come up with a table. At least in some. So these are just two skills we have. So first things first, small talking. We skipped small talking at the beginning, and we figured out that without small talking, no one used chatbot because it wasn't fun. Because the first thing people do, they try to small talk. So you have to have at least a bit of small talk there. And there are clever and awesome open source libraries you can use to build the chatbot in a So all chatbots usually state-of-the-art chatbots now use a way of interpreting your query as intent, entity, and action. So intent is, for example, I ask, what is the weather tomorrow? So intent would be weather. We are talking about weather. So it decides, okay, weather. How this is done, usually you look at the sentence, you maybe split it with using spacey, use some sort of machine learning on top of it, usually an SVM or something like that, and it just spits you out the probability that we are talking about. Next step is to extract entities. So entities would be tomorrow. So what was the weather tomorrow? Okay, entity tomorrow. So you're asking about the weather, and you're interested particularly about tomorrow. Next, I will translate this thing into an action. Which action should I take is, again, machine learning task. Usually this is solved using RNNs with LSTM cells or something like that. And I would recommend you to look at the RASA core and RASA ANDU and RASA base, which are open source products which you can use and build the chatbots on top. We use that and we are really happy with it. And it is quite simple. Okay, so let's take a look what our chatbot can do now. Sorry for the mess and sorry for showing SQL. We will hide that, but I just wanted to convince you that we are actually generating SQL from the human language and that we managed to get an answer. Sooner or later, we will skip all the part and come up only with the answer. So what's going behind the scenes? Behind the scenes, we have a spacey engine, and spacey engine understands a sentence and splits the sentence into parts of the speech. So it knows where it's an adjective, which words come together, and so on. So it's quite clever. It has some drawbacks, because if you had to uppercase letters differently and so on, and you have to be really careful. But spacey enables you to extract a graph of a sentence. So in SQL queries, if I say, could you please get me, that will be on the top. And then I will have a graph structure with all those words which come out. And then there is just a clever way to combine that graph and fiddle around. Well, it would be great to use machine learning at this part, but all the machine learning we use hides in the space itself, because we don't have a lot of training data. To get such training data, to get hundreds, thousands of such queries with the answers, would be a tremendous task. And now we are building logs of what the chatbot is telling, and maybe we will transition to machine learning at this point. But now the solution works, and it has a really nice consequence, which we haven't thought at the beginning. So if I have that query and I have it built, I can modify it. I can say, set date range from, and it just switches the date range. And I can say that in multiple ways. I can say that, not set date, but I can say, oh, let the date range be, and it will still understand me, because it's using machine learning behind it to understand what I'm talking about, and to extract those entities which are dates. And the fine thing is that now when you can ask the question, see the query, and modify it interactively, and add new columns, add new groupbacks, add new dates, add new segments, and so on, it becomes quite powerful and quite nice to use. Okay, so what's next? So we have those two building blocks. We have SQL engine, we have a little bit of small talk. Next, we are heading into insights generator. So we are, I would say, halfway into it. Maybe after a month or so, I will have something to share. But we are asking such questions like, which of those sequences, forgetting everything else, forgetting what they are and so on, which one of those are more interesting for you as a person? I would say the second one. Especially if it's business KPI, for example, ARPU. Okay? Average revenue is dropping, oh, it's bad. Yes. And the first sequence, it looks stable, it looks okay. But again, it depends on what we are talking about. But now to be proactive and to generate business intelligence insights like daily and pop you up with an insight like, hey, look, in that store, in that city, something happened and sales are dropping tremendously. It's that. Or it just comes up with another insight and says, hey, I see that last week you did something really good and sales increased in that particular segment. For example, your loyal customers which buy some product just jumped tremendously. Maybe you gave them some sort of promotion or something, just keep doing that. It's good. So such insights are possible, and the only thing you need is a clever segmentation, because to detect which graph is more interesting is quite a trivial task. Another thing we are looking into and we are exploring is causal inference. So what is causal inference? This thing here is a causal graph. So it says that this column, that could be the columns, some sort of things like events or whatever, and this is a causal graph which says that there is a cause there. So this event caused that event. Traditional methods will get it more or less correctly, and we found one method which works tremendously well, and it is called group lasso. So if you have time, look into it. And by group lasso, we can reconstruct causal graphs, and quite complex causal graphs, and, for example, understand what's going on in your business. I mean, how one event causes actions and how one event causes other events. And not only that, it has a nice consequence because I can look at the changes in causal graph, and I can look at that causal graph every day and see that, oh, something's changed. And if something changes there, if the structure of the graph changes, this means that it is a tremendously important business event. For example, some sort of a plan was added. Let's talk about telco, and you add a new plan. So the customers will migrate to that plan. So that plan will start to cause your revenue increase or decrease or whatever, and this will change the structure. So this way you can detect what's going on. Next, we think about adding ETL monitoring. What we mean here is that, let's say I have a query, and since I can write an SQL like with one sentence, I can say, hey, find me the customers from your which are generating most output last month or something like that. And I can just say, okay, now track those people. And it will track those people and use insight generated and causal inference to check what's going on with them, and come back to you and say, hey, take a look at those people like started to churn, for example, or started to generate even more revenue. So this monitoring is pretty important. And for sure we will have machine learning on top, which will try to extrapolate and try to say what will happen in a week or so. All of those things are proactive. What do I mean by saying proactive is that you don't need to go to the chat and ask the question. All of those will jump back to you and daily or weekly remind you that something is going on and update on the things you do. I mean, if you say, okay, that was interesting, it will remember that and reiterate, retrain, and come back with similar insights later on. So that's what we think AI is. And the only bit of piece we are missing, and this is really harsh piece, is that all of these techniques, which we built already, need clever segmentation. So, for example, you can say, okay, I can segment my customers by lifetime, I can segment them by behavior, I can segment them by ARPU level, by different metrics. When I have that segmentation, I can combine those segments and use all those techniques which I mentioned. But if I don't have those segments, what should I do then? So it's an open problem, and there are clever solutions. There's topological data analysis and different methods which try to extract interpretable and useful segments. come into simple solutions like that will not work because you will get nothing, things which do not make sense, and you need to get interpreted. Okay, so that's it, and this is bye-bye from my chatbot.
Thank you, Rokas. Does anybody have questions for him? Yes, I see one hand way back.
Hello. So, first of all, I have questions about your forecasting.
Yeah.
Where you had your graph, where you say that you forecast, you're very happy. So, what about confidence bounds? How confident you are that your forecast is actually going to be that, or not anything else?
Yeah, we went like completely different approach than you would get with the REMA or all those kinds of models, because all of those will give you a confidence bounds and all the things which are classical, but we wanted to try wild stuff. So we thought, oh, okay, let's think how a child would continue that drawing. So if you are a child and if you see a thing which is wavy and increasing, you will continue it that way. So that's why behind that it's a convolutional neural network which tries to replicate that. And this is completely different approach, and I can't evaluate error bounds using that method. And API will eventually have a list like of 10 or 20 methods which you can choose from. So this method will probably not get used like very often. But since it's R&D, we are trying stuff.
Yeah, but on the other hand, like you say that you cannot put an error bound. So what will happen if you put the forecast up and the actual data goes down?
Yeah, I will update it. I will it will retrain itself and update the prediction. So
yeah.
In a short term, the predictions are quite accurate.
In the short term, everything is.
Yeah.
Another question is like, okay, so your forecasting is based on one series, yeah? So you say that, for example, what can you say about the influence of other series?
Yeah, currently we are just looking at that problem, and for sure we will come up with a multi-series approach. Currently, AI handles only a single series, and there are open. We will come up like anomaly detection is also more valid if you look at the multiple series, because like, let's say the 2 series always is getting up, but you have never experienced a thing that one of them will drop and another will increase. So that's a strong signal of anomaly. So we will update it and we will add that definitely. So it will be also an anomaly detection and in forecasting and so on. We need to add multi-series analysis.
Final question.
But we have time.
So, for example, we have like these interesting events around the world. One of them is quite imminent, is Brexit.
Yes.
So, and as you know, Brexit can be, Britain does not know yet what kind of Brexit it wants and what it will get. So, for example, we can assume that, for example, you already know that Brexit can mean that like Britain goes away and loses all trading privileges and whatnot, and just renegotiates all the trade deals and whatnot. Another thing is that they will try to do as Norway does, like have some trade things left and whatever and whatnot. And you would assume that these types of scenarios would influence the outcome of your forecast, would be different in these type of scenarios. So what can your forecasting methods do like in these what-if scenarios? Because you cannot say like one line is one line.
Well, first of all, forecasting is really complicated problem, and we don't suggest to use our forecast trading or things like that. Just it's not meant to be doing that. It's just an experiment, and we are not using the forecast by ourselves like right now. We don't need that component, but we added it just for fun. So be careful.
So just so to sum up, you're not confident in your forecast.
No.
Thank you.
I saw somebody else had a question. Someone here.
No problem. I just wanted to comment. Colleague was asking about the errors of the forecast. So if your forecast is not.
I was just thinking if the forecast wasn't based on some imaginary data, so then you should have the actual results after some time, then you can check this out.
Yeah, we were checking it and well, as I told in the short term, it's tremendously well, better than ARIMA. You can read a paper on neural decomposition and you will find answers there. But the forecasting is just one element, and maybe anyone has questions about chatbot interface or something like that.
Right, I see one more question at the end. Does anybody else have a question? Last one. Right, that person can be the last one. Right, just right there.
It's more the question to Thomas. How can you tell that you're a robot?
Sorry, could you repeat the question again?
How can you tell if you're a robot?
Do you want to take this one?
We're in a matrix, as Daniel suggested earlier, so that's a fact.
Simple as that. Alright, so let's thank Rokas once again, and we're going to finish up our event with the last session. The last thing I want to introduce you to what's coming up in the next events, which is the AI Clinic. So basically, as you all seen, we all have some questions, but some of us actually have some case studies we would like to share. And for this, we want to introduce AI Clinic, where we're going to invite everybody from the audience to come up and present some issue or some challenge we face or something interesting we come up throughout the week or month or a quarter. So at this point, does anybody else have a question or something they would like to share? Keep in mind, my expectations are low. Alright, nobody, but in the future we're going to be introducing more of this, and next I want to really thank you all for coming and really encourage you to check out the stories we have on the walls and really see what other cities around the world actually have going. It's pretty interesting, and if any of you are interested in what's going to be next, please come to talk to me or any of my colleagues, and we're going to help you out and guide you. Because at the end of the day, global community is not just to be. If you have a challenge you want to face not locally but globally, there's probably somebody out there who has actually achieved or came over the challenge you're trying to face now. So reach out and we're going to try to help you. Like recently we had some people reaching out, and we managed to find them a really interesting case study which is happening in Sweden. But if anyone wants to find out more, again, come talk to me. And with that, I want to encourage you to do peer-to-peer networking. Thank you all for coming, and I hope to see you again in the next events. And please enjoy your questions and snacks at the back as well.